We left off, really, Kaya? That was not him. You think I can't tell the difference? All right. So we did the Xbox method of factoring trinomials before we went on break. There are some that we just need to memorize here. There are a few special factoring patterns that we need to know. The first one is the difference of two squares. If we have a squared minus b squared, that turns into a plus b times a minus b, Michael. If we have a perfect square trinomial, a squared plus 2 times ab plus b squared, that turns into a plus b, the quantity squared. Or if we have a squared minus 2ab plus b squared, that turns into a minus b, the quantity squared. We also have the sum of two cubes. If we have a cubed plus b cubed, that turns into a plus b times a squared minus ab plus b squared. Or if we have a cubed minus b cubed, that turns into a minus b times a squared plus ab plus b squared. So we have all those special factoring patterns, and we have to memorize them. Once we memorize them, we can move on and do these problems, hopefully with ease. This is one of those things where if you don't know it, you're just not going to be successful at getting them done, right? You're just stare at your quiz, test, whatever you might have, and you'll be like, I don't know what to do. So we take a look at the first one, 27x cubed plus 64. Bethany, who am I picking on? Kelsey. Kelsey, out of all the special factoring patterns at the top of the page, which one might that match up with? Because we start off with a guess, a hypothesis, a conjecture, if you will. No. Which one do we which ones does this match up with on the start? Is this difference of two squares, perfect square trinomials, sum of two cubes, difference of two cubes? What do you think this one might be? Michael? Sum of two cubes. What tipped you off, Michael? The 3. And what else? Well, and it's adding. Those are the only two things I'm looking for the tip-off. Okay? Cubed and adding. Sum of two cubes. So now we have to make sure that they are cubes. Is 27x cubed some item cubed? What? What would give me 27x cubed if I cubed it? 3x cubed. 3x cubed. Is 3x times 3x times 3x 27x cubed? Yes. Is 64 something cubed, Destiny? 4 cubed. Nope, just 4. There's no x on the 64. So 4 cubed. 4 times 4 times 4 is 64. So 27x cubed plus 64 is something cubed plus something cubed. So what is 3x? 3x is my, looking back at the formulas, 3x is my a, and 4 is my. So now I just plug those values into the formula and I factored it. I'm done. So this 27x cubed plus 64 equals 3x plus 4 times 9x squared minus 12x plus 16. I'll pause. Make sure we understand where I got everything. Look back at the sum of two cubes formula for factoring the sum of two cubes. Check what I did.
So we just have to know those?
Yes.
No chart, nothing, anything to
Know them.
not even like a flashcard.
You could make your own flashcard and know it before the test. Otherwise, why make it a flashcard?
So we could use
Just bring your notes.
What if I like get it tattooed like on
if you are willing to go for that, you do you, man. All right.
Wow, that's a good idea.
So, no, it's got to be a pure, like a real tattoo here, like the real thing. So, Mia. Okay. All right. Shh. Focus, guys. All right. Breaking it down, gentlemen. So if I have a cubed plus b cubed, right? That turns into a plus b, we good? Times a squared, so 3x squared would be 9x squared, minus, instead of plus, a times b, 3x times 4, that's 12x, plus b squared, that's 16. 4 squared is 16. We're good? Cool. All right, let's go ahead and try out the next one. 8x cubed minus 1. Yes, Kaya. A little excited. Difference of 2 cubes. Let's go ahead. 8x cubed is what cubed? 2x. 1 is what cubed? 1. Just so we can identify our a and b. So then I break it out the way of factoring the difference of 2 cubes is. That'd be a minus b times a squared, and if I square 2x, I get 4x squared, plus a times b plus b squared. Yes, Leslie. No. Yes. How did I get 2x cubed? Because 8x cubed, I need to, every time, if you look at the formula, Michael, it says if I have a cubed minus b cubed. So I have to have something cubed. The x is cubed, sure, but the 8 is not. I need to turn this whole thing into one item cubed. I need to turn it into one item cubed. Just like up here, technically the 27 is not a cube. So turn it into a cube. How do I do that? If I make it a 3 and cube it, that is 27. That's one and the same thing. It's like if I said, is 9 a square number? Okay. What is it squared? It's 3 squared. So to show me 9 is a square number, you show me that 9 is the same thing as 3 squared. All right, these can get a little more complicated than my notes. I might even do an extra example beyond it. So we've got 40x to the fourth plus 5x. This will be very similar to the last one, but it's something that students forget, and it's something that students forget, even though I said it twice on Friday at least, and I'm saying it again right now, and I'm trying to draw extra attention to it. If there is something that I can factor from every item, I do that first, and then I continue. Because 40 is not a cube. 5 is not a cube. 40 is not a square. 5 is not a square. But there is something I can factor from both of those before I start. 5, x. These both can give up a 5, and they both can give up an x. If I factor 5x out of 40x to the fourth, what do I get? 8x to the third. There's that cube. If I factor 5x out of 5x, what do I get? 1. Because I took one of the x's out of it. Gabriella, what does that look like? 8x cubed plus 1? Top, it's one of those things. What is it? Sum of two cubes. Matter of fact, it's almost identical to the previous one, except it's a plus instead of a minus. With that in mind, if you guys still want to see your A and B, I can still put this as a step. And then I'm going to get 2x plus 1 times 4x squared minus 2x plus 1. Yes? Thought you were checking me off. Thought you were threatening me. Thought you were looking at your hit list and you're like, got a problem, Dimitri?
Is this basic algebra?
Yes, why?
Because that's why I get it. Because it's not shapes. I'm not good at shapes at all. That's what. Yeah, shapes and graphs. Yeah. Wow. Can't believe we did that. I don't know if that worked out. Oh, it did. Cool.
Mia,
I don't understand the last one.
from here to here?
Yeah.
So at the top of the page it says sum of two cubes. And sum of two cubes, if I have something cubed plus something cubed, that turns into something plus something, so 2x plus 1, times the first thing squared. 2x squared is 4x squared, minus the two numbers multiplied. 2x times 1 is 2x. And the last thing squared, which is 1 squared. And difference of two cubes. Kelsey, pick somebody. Holly. Holly. What's the difference between those two formulas?
They switch, so in the a squared minus ab, on the difference of two cubes, it's a squared plus ab.
That's the only difference between them?
Well, in the beginning part, it's adding.
Okay.
So, in the very first part, the sum of two cubes is adding, then subtracting, and then the difference of two cubes is subtracting, then adding.
Okay. So other than that, they're the same. So you can kind of try to remember what Holly just said, right, Seth? She said on the adding one, it starts off adding, then it's subtracting. And then on the subtracting one, it's subtracting, then it goes to adding. Other than that, they are the same. It's a squared, ab, b squared. In America, we can remember the acronym SOAP. SOAP. Same, opposite, always positive. Okay, they're always the same sign, then the opposite sign, and the b squared is always going to be positive at the end. So let's get the last two in, and then an extra example before I cut you a little loose. Riley Parrish. I think your middle name's Lou. Just because I want your name to be Riley Lou. Maybe Lee again. Middle name Lee. Riley Lee. Holly Lee.
Yeah, because my grandma's maiden name is Lee. My mom, yeah.
My dad wanted to name me Pam.
Like your first name?
No.
Your middle name?
No, he wanted first name. He wanted to name me Pam. Pam Parrish. I was so happy.
I am too, because it wouldn't be fun to run around going being called Pee-Pee. So, alrighty. 9x squared plus 24x plus 16. Okay, so we might look at this. An Xbox will work on this. Let me be clear. Xbox will work on this. But we might recognize that this could be one of those things at the top of the page. And if it's one of the things at the top of the page, we don't need to use Xbox can. So Holly, pick someone for me. Gabby. Gabriela. So if we're looking at the top of the page, what could this one be? Difference of two squares will only have two numbers and a minus between them. Difference of cubes will have two numbers and a minus between them. A perfect square trinomial. Okay. This is a reason why to pick on you more. Okay. This could be a perfect square trinomial. But to check whether or not it is a perfect square trinomial, we have to do a quick mental check first. Quick mental check before we see if it's a perfect square trinomial. So, Gabriela, we're still on you here. The first item, 9x squared, okay? Could that be something squared?
Yeah.
What? 3x squared. 3x squared. So first checkbox mentally, yes, so far it's shaping out to be a perfect square trinomial because the first item is something squared. It is 3x squared. The last item, Gabby, is that something squared?
Yes.
What is it? 4 squared. Okay, still shaping out to be pretty good. The first item is something squared. The last item is something squared. The middle one's the most confusing part, so make sure we're focusing along first, okay? Is the middle number 2 times the first times the last? It is. 2 times the first times the last. 2 times 3 is? Times 4? 24.
Oh, I didn't even think of it like that. I thought it was 12 times 2.
Okay? That's fine. Okay.
Come again? One more time.
Yeah.
So it sticks.
You just repeated yourself just three different ways. Hold on. Wait a second. Come again. One more time. Just so it sticks. Alrighty. So in order for Bethany, in order for this trinomial to be classified as a perfect square trinomial, right? The first number has to be something squared. 9x squared could be turned into 3x squared. The last number has to be something squared. So 16 is 4 squared. And the middle one had better be whatever that is times whatever that is times 2.
Always times 2.
Yes. Look at the formula, Bethany. Do you see a 2 in there? All right next to all the letters?
I thought you were just doing it, and I was like, whoa.
The perfect square trinomial.
Oh.
Ow. Okay.
Make this so where it's left-hand compatible.
I'll get right on that. Okay, so all my left-handers next year.
Thank you.
Yeah.
For that. So I know.
Okie dokie. So if this is true, check it is true, right? Then it's just simply going to be A plus or minus whichever, depending on whatever sign is in front of the middle one. Okay, A and then plus because of that plus there, 4 squared. It is factored.
Oh, because someone asked me for that.
Gabriella, pick someone. Kaylee. 81x squared minus 49. Kaylee, which one does this look like it'll match up with? Difference of two squares. So let's check it out. Can 81x squared be turned into something squared? What? 9. X. Can 49 be turned into something squared? 7. Great. My A is 9x. My B is 7. 9x plus 7. 9x minus 7. I'm done. Ingenue? Your ingenue is your naive person in a play. It's usually portrayed by a female that she needs to grow and experience the world, and so everything's seen through her eyes. It's a coming of age story usually. Ingenue?
Oh, I said engineer.
Oh, engineer. An engineer is somebody who works in the sciences with physics, and they can either be an electrical engineer or a mechanical engineer, or, you know, all civil engineer. All these things are basically applications of physics into real-world technologies.
Yeah, that is what I am.
Yeah, okay. Ingenue?
Ingenue.
Yes.
Is there not a sum of two squares?
There is not a sum of two squares. That gives you imaginary results. Okay. I don't want to steer you wrong just in case Gansky destroys me. Gansky is capable of destruction. Nope. That's not how it's spelt. I didn't think that's how it's spelt when I saw it. Ah, there it is. Okay. There you go, Bethany. No. Innocent and unsophisticated, not dumb. There's a difference. It's the why. So you're playing the ingenue when you are the girl from Kansas who's come to LA to become an actress. Right, you know. Bethany. So. Huh? Alrighty. Who'd you pick again? Oh, no, we already did that. Kaylee, you already finished. That was easy. All right, let's get something a little bit more complicated, just so that way we're not intimidated when it comes to our worksheet. Okay? This is not on the notes. We can get something that's a little bit more. Let's do. Okay. If I gave you this, there are two ways we can factor it. This is a little bit underhanded and sneaky of me, and for some reason, right away on the worksheet AB, they gave problems like this and kind of ran into a critical stop third period, which is why I'm cutting it off at the pass now and handling it here. What does this match? Kaylee, pick somebody. Dimitri, what does this match from the top of the page? What x to the 6th minus 64 could be what?
From the, like, where it says, like, the box for the special. Okay. That could match. Difference of two squares?
Sure. X to the 6th is a square. 64 is a square. Kelsey, what could this match? Difference of two cubes. X to the 6th is a cube. 64 is a cube. So there are two ways you could go with this. So let's take a look at that. I don't know if you want to write it down, where you want to write it down. Okay, x to the 6th is what squared? X to the 6th is what squared? x cubed squared. A difference of two squares is something squared minus something squared. Done. That's x to the 6th still, and that's 64 still. No, not done yet. I've actually got to factor it. Let's not goof off over there, ladies. Okay, x to the 6th is what cubed? Is what cubed? X squared. X squared cubed, that's still x to the 6th. 4 cubed, that's still 64. Both of these, I'm factoring them simultaneously, side by side in front of you guys. Okay, these are two different paths I could take to get correct, but not the same answer. Both correct, and numerically, mathematically, they are the same answer, but they're not going to look the same at the end of this all. Is everybody okay that if I wanted to call these both squares, I could do that? If I wanted to call them both cubes, I could do that. Is everybody all right with that? All right. So if I have difference of two squares, that turns into x cubed plus 8 times x cubed minus 8. That's how difference of squares works. Difference of cubes. I know you guys don't have the formulas down in your head like I do, okay? Difference of cubes, this would turn into x squared minus 4 times the first one squared, x to the 4th, opposite sign, plus 4x squared plus 16. 30-second pause. Oh, 45-second maybe. I just applied the difference of square formula on the left, and I applied the difference of cubes formula on the right. Just applied the formula. A squared plus a times b plus b squared. My a was x squared, my b was 4. Okay? Is everybody okay here? Yes. Okay. Here's the issue when you run into the problems like this. We're not done on either of them. They both can be factored one more time. Dimitri, who do you want me to call on? Raymond. Raymond, on the left-hand side, both of those can be factored. What are they both? Well, not both the same thing. They're each different things. What's this one, Raymond? Out of the top of the page, which one is this? This actually matches something. Sum of two cubes. What's this one? No? That's a difference of two cubes. This is a sum of two. So sometimes they can just keep going. This is sum of two cubes. This is going to be x plus 2 times x squared minus 2x plus 4. And this one's going to be x minus 2 times x squared plus 2x plus 4. Now it's factored. That's really obnoxious. This one's not nearly, well, actually this one is as obnoxious.
Wait, you finished solving it yet? The cubes one?
Oh, actually this one is, yeah, the cubes one done. We're on this one now. No, this one's still got more to go as well. Okay, you guys don't know how to factor this one. That's a problem. However, this is something. What's this one right here on the left? Easy one.
X minus 2.
Times, no.
Times
Bethany, just stop.
Times 5.
At the top of the page, which one's this one?
Oh.
Difference of two squares. Thank you. Difference of two squares. So this is going to be x plus 2 times x minus 2. And then you guys don't know how to factor this. And we can see this one would be done now. Slightly different. These two larger parentheses obviously equal this one. Well, I say obviously, but I'm not trying to say that you guys necessarily see it. But you guys could have taken two different paths. As you work through the workbook today, I'm giving you quote-unquote homework. This is going to be on your honor. You can prove to me the quality of student you are, or that you'd like to judge me, that you'd like me to judge you by. Okay? I'd like you to please do the AB workbook, which is not what I collect, so it's not homework, but I'd still like you to do your AB workbook numbers 1 through 12, because we're not going to have time in class. You're going to have 5 minutes to start working on those. What's the big thing I told you to remember, to always look for? If you can factor something from every term before you start, do it. Right away, in a bunch of the problems in that workbook, right away they bring that concept in. People in third period, I cut them loose to do it, and they're like, Mr. Bates, I already don't know how to factor the number 1. Yeah, you got to factor something out, and then all of a sudden it becomes obvious what to do. What do you factor out of number 1? 3, and you're going to get n squared minus 48 or something like, or 16. Okay, n squared minus 16, and that's difference of two squares. You factor from that point. Okay. So please do those.